Hello everyone, in lecture 2.5 we had initiated the dynamic analysis method, particularly response spectrum method, in which we have devised various matrices related to mass and stiffness of the structure, and based on these mass and stiffness matrices of the building we can formulate the eigenvalue problem, where upon solving the eigen problem we shall be able to obtain the fundamental frequency and thereby the modes of oscillations corresponding to these natural frequencies. Upon finding the dynamic properties of building, we can further take our discussion to estimation of design seismic load using response spectrum method. So, in today's class we will take our discussion forward. So, in this class we will take our discussion forward to understand how do we estimate design seismic load on a building using response spectrum method. In response spectrum method, the first step is to determine various dynamic properties of building. It includes natural periods and modes of oscillations. It also includes modal participation factors and modal masses. We shall come to know what are these dynamic properties as well. Once we have the dynamic properties of the building known to us, we shall determine the lateral force at each floor in each mode. So, here we will consider different modes separately, and then we shall be able to obtain the design force at various floors in this case. So, here we shall use a design response spectrum which is prescribed by our code IS 1893 part 1 2016. The response spectrum will depend on natural period, damping ratio of the system as well as the soil type. We shall look about this design response spectrum as we go through today's class. After determining the lateral force at each floor in each mode, we shall find out the design lateral force at all floors considering all modes. For that, what should we do? We should first find out what shall be the story shear force in each mode. Then for each mode we have the story shear. Then what we will do is that we will combine all those modes to find the story shear forces due to all modes, and from there we shall find out the lateral forces on various floors due to all modes. We will go through all these steps as we go through today's class. Then after that we shall distribute the floor forces among various lateral load resisting elements based on floor diaphragm action, whether the slab is able to provide a rigid diaphragm action or a flexible diaphragm action. Now, good thing about dynamic analysis method as compared to the equivalent static method is that different modes of oscillations are also considered in this case. It is not only based on fundamental natural period, but it is based on various modes of oscillation which are pertaining to different natural periods of the building. This makes it applicable to all the buildings. Why? Because in equivalent static method we were estimating the natural period of the building. So, the natural period of the building can be estimated well only for regular buildings. For irregular building, the estimated natural period may not match properly with the actual natural period of the building. So, therefore, unlike equivalent static method, the response spectrum method is applicable for all the buildings. Here we shall look into two approaches, response spectrum method and time history method, or sometimes also called as response history method. So, now let us start our discussion further into the response spectrum method, in which upon conducting the undamped free vibration analysis we were able to obtain the mass and elastic stiffness matrices M and K appropriately. These are also listed over here. So, M1 and K1 represent the mass and the stiffness of the first floor level, that is M1 is the seismic mass at the first floor level, K1 is the stiffness of the first story level, and so on. Then we shall establish an eigen problem from which we shall be able to find out the value of natural period and mode shapes. So, for a 10-story building, we shall usually lump the masses at various floor levels, which means for a 10-story building there will be mass matrix and stiffness matrix which will be having size of 10 by 10. So, in that case we shall be able to obtain 10 values of natural period, and for each natural period we will get a mode shape which precisely describes how your building is going to oscillate in that natural period, or when the excitation frequency matches that very natural frequency of the system. Then based on this we shall calculate the modal participation factor given by this expression and modal mass given by this expression. Now these expressions are also available in IS 1893 part 1 2016, as well as you can also look into any other standard textbook on dynamics of structures or structural dynamics. Now what is the difference between modal participation factor and modal mass? Modal participation factor gives you an estimate that how much that mode contributes to the total oscillation of the building. So the oscillation of building comprises of various modes which we have found out by solving the eigen problem. So the fundamental modes, let us say the first mode, will contribute heavily to the total oscillation of the building. As we proceed further to higher modes, the modal participation factor should drop down or should go down. At the same time, the modal mass represents what is the amount of mass that participates in any mode of oscillation. So what you will typically observe that for fundamental modes the modal mass is also high, and as we move to higher modes, lesser and lesser mass contributes to the or participates in the motion, and which means that the modal mass is likely to reduce for higher modes. The expressions are given over here for both modal participation factor and modal mass. It will be more clear as we go through the illustrative example in the next class. Now once we have the dynamic properties of building known to us, we shall find out various other factors which are to be used in determining the lateral floor forces in each mode. What are these factors? These factors will come from the response spectrum. The code IS 1893 part 1 2016 prescribes a design response spectrum which depends on natural period of the building, damping in the building, as well as the soil type. Now how many modes should we consider? For that, if your cumulative modal mass exceeds 90%, it is all good. So which means, let us say that 82% of the mass contributes to mode 1, which means that the modal mass for first mode is 82%. Let us say for the second mode we have the modal mass to be 15%. So 82 plus 15 becomes 97, and in that case you can say that considering two modes makes sense. In many of the cases you will find that considering just one mode makes sense. However, we should be aware how should we calculate it for different modes. Now the design lateral force at any floor I in a mode K shall be given by this expression, AHK multiplied with phi ik multiplied with pk multiplied with wi. Let us understand what are these. We are talking about floor I and mode K. So wi is the seismic weight of the floor I, pk is the modal participation factor for the kth mode, phi ik represents the mode shape corresponding to oscillations. Then AHK is the design horizontal seismic coefficient for that very mode, that is mode K. Now, this is equal to Z by 2 times of SA by G divided by R upon I. Now, Z is zone factor. We have learnt about zone factor while we were studying about equivalent static method. It depends on the site location based on regional seismicity of the site. SA by G is the acceleration coefficient, and therefore, it depends on which mode you shall be considering. Z does not depend on which mode you are considering. Similarly, the response reaction factor and the importance factor depend mostly on structural system and functionality of the building respectively, and these are not influenced by the concerned mode. So, therefore, only SA by G will be affected by which mode are we considering. Okay, so once we have the design lateral force at floor I in mode K known to us, now let us look the design spectra or the design response spectrum which gives the value of SA by G. So, as expected, it is a function of natural period of the building. Natural period is on the x axis. On the y axis we have SA upon G. At the same time, if you change the damping, the curve will change completely from one curve to another, but here the three curves shown over here are for variation in soil type, that is the underlying site, if it is rocky or hard soil or medium soil or a soft soil. The value of SA by G is also given in terms of expression in our code IS 1893 part 1 2016. Now, this very response spectrum is slightly different from the spectrum which we saw in case of equivalent static method. Can you note the difference between the two response spectra? The difference is only for extremely stiff structures, where for extremely stiff buildings, if you are using a response spectrum method, then you can allow this reduction in design seismic force, because the design seismic force is proportional to SA by G, and here a reduction in SA by G will lead to reduced seismic force. Why this reduction is allowed? Because response spectrum method is little more evolved than equivalent static method. It takes into consideration various modes of oscillation, and therefore, we give some relaxation in the calculation of design seismic force for extremely stiff structure. For extremely stiff structure, since it will move in tandem with the ground, so there shall be lesser force which you need to design the structure for. So, once we have the SA by G known to us, we can calculate the lateral flow forces in each mode as we have discussed in the last slide, and then from there we shall try to find out the story shear force in each mode. How do you obtain the story shear? It is calculated as the sum of lateral floor forces above that story which is under consideration. Okay, any lateral force which is being applied on the building frame above that story which you are considering, then that shall give you the story shear force in each mode. Now, we need to combine different modes. So, for combining different modes, we have two modal combination possible. One is using SRSS or another is CQC. SRSS stands for a square root of sum of squares, and CQC stands for complete quadratic combination. Now, for SRSS, if you have the story shear known to you for a given story for different modes, you just square those values, take the sum and then take the square root. That will give you the story shear force due to all modes. Here we are not going into depth of CQC method, but you can always have a look at the relevant references. Okay, once we have the story shear force due to all modes, we can take the difference between a story shear for a story above and below to find out what is the lateral floor force at that floor for due to all modes. So, we have the stoichiometry known to us considering all the nodes. So, we have the stoichiometry known to us considering all modes. So, if we take the difference between a stoichiometry for a story above and below, it should give us the lateral floor force due to all modes. Once we have an understanding of lateral floor force considering all the modes, or the stoichiometry considering all the different modes, then we can consider distributing the floor force among various lateral load resisting elements such as columns and shear walls. This process will be exactly same as equivalent static method, where if your slab provides a rigid diaphragm action, then in that case the distribution will be in proportion to the stiffness of various lateral load resisting elements. If your slab is unable to provide a rigid diaphragm action, then it will come under flexible diaphragm action category, and in that case we have to distribute it considering flexibility of the diaphragm. The distribution can also be done in proportion to the tributary area based on some global codes. Then we also discussed about the general thumb rule for rigid diaphragm action in case of monolithic construction or a precast construction. So, we have seen this when we are looking into equivalent static method. So, in this class, summarizing, we have looked about the dynamic analysis method, particularly response spectrum method, how are different steps executed. We start with determination of the dynamic properties of the building, then we move to estimate the design seismic load considering all the different modes, then we move further to distribute these floor forces among various lateral load resisting elements. Okay. In the next class, we will illustrate the same using an example problem. Thank you.